Hello everyone. In this session, we'll discuss about the types of supports, beams and loads. First, we'll discuss about this types of supports. So coming to the types of supports, basically three types of supports are used in structures. These are roller support, pinned support and fixed support, and the fourth support is also called as a symbol support. And every support has its own field of application. So supports are used in structures to provide the stability and strength. And here the various types of supports are used in structures. In that, first we'll see here the fixed support. So the fixed support. So here what is fixed support is nothing but it is a type of support and it which capable of resisting all types of loads, means horizontal loads, vertical loads as well as the moments. It does not allow any type of rotation and translation to the structural members. It resists all the vertical loads, horizontal loads and moments. So this type of support is also called as a rigid support. Means fixed support is also called as a rigid support. So in this figure, here you can see the reactions acting in the fixed support is shown in this figure. One is horizontal, vertical and moment. So for example, uh, the fixed support, we can see the flagpole is fixed in the concrete base is the best example of fixed support. And also the beam is connected to the wall. That is also best example for this fixed support. And this fixed support is provides the greater stability to the structures compared to the other supports. So this is about fixed support. Now next here the next one is pinned support. So here the pinned support allows rotation to occur but no translation. Means in this it is a type of support in which it resists the horizontal and vertical loads but is unable to resist the moment. In this reaction force you can see here one horizontal force and one vertical force is there. Means it can resist only the horizontal and vertical loads. It unable to resist the moment. So for pinned support, the pinned support is a two support reactions. Those two support reactions are vertical reaction and horizontal reaction. It does not allow translating in any direction. This pinned support allows only rotation, only one direction, and it resists the rotation in any other direction. And this pinned support is also known as a hinge support. This pinned support is also called as a hinged support. Best example for this pinned support is doors and windows. And the next one is a roller support. So here the roller support, it is a support which is free to rotate and translate along the surface on which they rest. It can resist a vertical force but not a horizontal because the roller is horizontal. In this is the reaction force if the roller is provided in horizontal reaction force diagram. So the roller support has only one reaction. This reaction acts perpendicular to the surface and away from it. In this figure you can see that. The best example for this roller support is roller skates. The roller skates resist the vertical loads of the person standing on it. When the lateral loads are applied by the persons, then it starts translating. The translation is due to its inability to resist the lateral loads. This is about roller support. Now, in this diagram, here you can see The first one is roller support, second one is pinned support and fixed support, simple support. For roller support, only one reaction, that is here the horizontal rollers are provided. So perpendicular to that means that is vertical load, resisting vertical load. And for pinned support, this pinned support is also called as hinged support. For this horizontal and vertical. For fixed support, here the three resisting forces, one is the horizontal, vertical and moment. For simple support, it can resist only vertical loads. This is about types of supports. So based on the types of supports, we can classify the beams. Now let us see the types of beams. First, we'll discuss what is beam. So here, the beam is nothing but it is a horizontal structural member or horizontal structural element. This beam primarily resists the loads applied laterally to the beam's axis. So here the beams are generally characterized by their manner of support. So based on the supports, here the beams are divided into, means classified into 6 different types. Let us see, the first one is simply supported beam. So in the simply supported beam, this beam rests on both ends, means it contains one end is pinned support and other end is roller support. So based on the assigned load, it sustains shearing and bending. So in this figure, you can see this end is hinge support or pinned support and this support is roller support. The beam is placed between the two end supports. One end is hinge support and another end is roller support. Means it is supported or resting freely on the two supports at its ends. And coming to the next one, cantilever beam. So if a beam is fixed at one end and said to be free at the other end, it is termed as cantilever beam. So in this figure you can see one end is fixed end and other end is free end. So this type of beam is generally called as cantilever beam. And so in general, the cantilever beams allow the creation of a balconies or bridges, some bridges or windows. And next coming to the fixed beam. So here fixed beam is nothing but it is supported at both ends are fixed because to resist the rotations. And this fixed beam is also called as built-in beam. Built-in beam. Fixed beam is also called as built-in beam, and in this fixed beam both ends are fixed supports. And coming to the overhanging beam. So next one is overhanging beam. In this overhanging beam, so the beam is extend beyond the supports. If suppose this is the starting of the beam and ending of the beam, at one end is hinge support and here there is no support. Here one roller support is there. So here beyond this roller support the beam is extended, means this is the hanging portion. So the beam at this portion the beam is hanging. So this type of beam is called as overhanging beam. In this figure you can see only one side of the beam is hanging. If suppose suppose this is a beam, one support is provided here and other support is provided here, means this is the overhanging portion and this is also overhanging portion. In this figure you can see both sides the beam will be overhang. So this type of beams are generally called as overhanging beams. And the next coming to the continuous beam. So we know that in the name itself says the continuous is nothing but processing. Means here the continuous beam has more than two supports distributed along its entire length. So suppose this is a beam, here continuously the supports are there. One is the hinge support, roller support, roller support, roller support. In this beam the supports are four supports, means more than two supports, then the type of beam is called as continuous beam. And the next one is proper cantilever beam. So already we know that the cantilever beam having one end is fixed and other end is free. Now in this proper cantilever beam, if suppose this is a cantilever beam, while applying a load on this free end, the beam will yield like this. So how to resist this yielding or bending is nothing but have to apply opposite direction force. That opposite direction force is called as prop. So this type of beam is called as proper cantilever beam. Here the cantilever beam whose one end is fixed and other end is provided with the simple support. That simple support is called as prop. What is the use of this prop is nothing but you can resist this bending or yielding on cantilever beam. So this type of beam is called as proper cantilever beam. Now let us see the types of loads. So here the bending or slope or deflection or shear force, here all these terms are based on the external loading condition. How much of load is acting on the beam and what is the type of load. So here we'll discuss about the types of loads. Majorly the types of loads are three different types of loads. One is point load, uniformly distributed load, uniformly varying load. Now let us see what is point load. So here the point load. So this point load is also called as a concentrated load. Suppose this is a beam and the length of the beam is L. The point load is acting at the center of the beam. Means this force F is point load. This point load is acting at this point. So here is considered to act at a point only. This is point load. This load is considered at this point only. That force is acting at this point only. That's why here this type of load is called as point load or concentrated load. Coming to the uniformly distributed load. Uniformly distributed load is nothing but the load is spread over the beam. That rate of loading W. That W is acting from the point A to point B. Means along the length of the beam, the load is distributed. So along the length of the beam and the load is W. So W per L. This can be expressed as W Newton per meter run. In point load, only that load can be acting, that is considered, or that acting at one point. So that is W. And this is uniformly distributed load. The load is spread over the beam, the rate of loading along the length of the beam. Coming to the uniformly varying load. The uniformly varying load is spread over a beam. The rate of loading varies from point to point along the length of the beam. Now in this first figure you can see this is point A and this is point B. At point B the load is 0. Coming to the point B the load is maximum. Means here from point to point the load is varies. From means here at one end the load is 0. That from 0 to increases uniformly to the other end. So during this increasing of the load, we'll get the type of load, shape of the load is triangular load. In the second figure you can see here at A point some load is there and B point the maximum load is there. So from A point to B point the load increases gradually and uniformly increases the load. And coming to the third figure, in this figure at A point the load is maximum, at C point the load is 0. Means from this point to here the load is increases uniformly up to A point. So these are the, and one more uniformly varying load is there. If suppose this is a beam, point A and point B. So at A point, at B point, the load is 0. but at the center we'll get the maximum load. Means from here to and here to the load is increases gradually like this. The load increases up to the maximum point, then again decreases. Here also we'll get triangular type of loading. So this is a type of uniformly varying load. So these are the types of supports, beams and loads. Thank you.